Hi guys, this is Nikhil from RLC again. Now I will discuss the solution of the second analog challenge which was posted yesterday, and the circuit diagram given was something like this. As I was telling in the question only that there was a NPN transistor, and you are supposed to find out the DC current gain, which is the beta value you have to find out. First, what is beta? So beta is also called as transportation factor in a transistor. So beta is given by IC by IB, the ratio of IC by IB. What is IC? Current flowing in the collector terminal. What is IB? Current flowing in the base terminal. Now you have to identify where is the base, collector and emitter. As I was already telling you, this was the base and this is the collector and this is the emitter. Okay. Now the current flowing in the base is IB, that is what I was telling you. So where will be the IB current? Here will be the IB current, that is the base current. Next, you are supposed to find out what is the IC current. What is IC current? Collector current. Now current collector will be flowing from top to down. Why top to down, sir? Why? Because you are supplying the collector current from the source. The entire power for this entire circuit is from the top. 10 volts source is there. So from this source it will be forcing some current of IC through this collector terminal, and this is the RC, collector resistance. Okay, collector resistance, or we can also call it as the load resistance also. Okay, load resistance or collector resistance. We connect the load in the collector terminals. Okay, you have to keep this point in mind. Understood? Right. Next, we are supposed to find out this beta. Okay, the gain beta. So for that we have to find out the value of IC and IB, that is what I was telling you. And what is the next another data given in the question? He has given you that the voltage drop between base and emitter terminals is 0.6 volts, he told you. Anything else did he give you which I did not mention? Yes, as you could see in the diagram, he told you that the current entering into the Zener, okay, Zener branch is 0.5 milliamperes. That thing was explicitly not mentioned by me in the last class, so that you must have observed in the circuit diagram. Understood? So we will take into consideration of this one also. Now suppose I want to find out the value of IB. What would be the IB value equal to? Just consider the node over here. At this node you see there is supply 10 volts. So this supply 10 volts will be injecting some current into this 4.7K, and this 4.7K which is carrying this current will be entering into this node, and it will divide into base current, and remaining will go into 0.5 milliamperes. Understood? Remaining will go into the Zener as a 0.5 milliamperes. Now by using the basic Ohm's law principles only, we can find out what is the current which is coming into this, what is the main supply current coming through this 4K resistors. So as already given in the question, the Zener voltage is how much? The Zener voltage is 5.3 volts. That means you know that Zener is used as a voltage regulator. That means it will always try to maintain a constant voltage irrespective of the supply side conditions or the load side conditions. Now he told that Zener rating is 5.3 volts, means Zener is connected to this node and this node, isn't it? Zener is connected between these 2 points. So between these 2 points, what will be the voltage? 5.3 volts. What is this point indirectly? It is reference or the ground, isn't it? So I can tell that with reference to ground, this node voltage is how much? 5.3 volts. 5.3 volts, isn't it? Now what I will do is, I will apply simple Ohm's law. You see here, okay, the voltage at the beginning is 10 volts and voltage at this node is 5.3 volts. Between these two nodes only, the current is circulating across this 4.7K. Yes, I can find out the current which is flowing here. So what would be that current equal to? That current would be equal to the difference voltage by the resistance. So 10 volts is the supply, and at this end the voltage is 5.3 volts divided by what is there? 4.7K, isn't it? 4.7K. So this will come out to be how much, guys? It would be equal to 1 milliampere. So the current flowing here is 1 milliampere. Now apply KCL at this node. Apply what? KCL, Kirchhoff's current law. So from this, already in the question is given that here it is 0.5 milliampere which is going into the Zener. If incoming is 1 milliampere, 0.5 is diverting here, what would be the base current or the remaining balance current? That would be equal to 0.5 milliamperes. Understood? So by simple KCL and Ohm's law, just nodal analysis, I can say I have got the value of what the base current is equal to 0.5 milliamperes. Okay, sir, very good, nice. Now what we will do? Now we have to find out the value of IC. You should know that IE equal to IC plus IB. Okay, please keep this point in mind, never forget this. Okay, IC plus IB is equal to IE. So I know the value of IB. I have to find out the value of IC. Can I do something to find out the value of IE? Yes, there is a way. What is that way, sir? So what is IE? Emitter current. So emitter current is something which is flowing like this. Understood? Emitter current is something flowing like this. Now what I will do is I will apply KVL. Okay, I will apply KVL in this this loop. Okay, in this loop. In this loop, what you are having? You are having some voltage, 5.3 volts at this point, isn't it? Now you travel from this point to ground, okay, through the emitter terminal. So when you are coming like this, what you are having plus to minus 0.6 volts. That means you are traveling from plus to minus means what? High potential to low potential. That means there is a drop in voltage. By how much volts? 0.6 volts. So 5.3 volts minus 0.6 volts of the drop. And again, what else is there? There is another potential over here, plus minus, isn't it? Wherever the current enters into the resistor, that point should be taken as plus. I was already telling you every time. So anyhow, this voltage would be having, this voltage drop across the 470 ohms would have the plus and minus terminals like this. So plus to minus, again the drop in voltage is equal to how much? IE into 470 ohms, isn't it? Equal to 0. So this is going to be your KVL equation. From this, I could solve this and I can find out the value of IE, isn't it? What will be the value of IE? You will get 4.7 volt by 470 ohms. So upon solving this, what you are going to get? You will be getting IE as 10 milliamperes. Okay, I got IE as how much? 10 milliamperes. So now, can I find out IC? Yes, I can find IC. From here you see, IC is equal to how much? IE minus IB. Understood? What is IE I got? 10 milliamperes. What is the IB I got? 0.5 milliamperes. So what is going to be the value of IC? IC is going to be 9.5 milliamperes, right? I got my IC, I got my IB. I got IC is equal to 9.5 milliamperes. Very good. Now I can find out the value of beta. So what is beta? IC by IB. How much IC I got? 9.5 I got 9.5 milliampere, and IB is 0.5 milliampere. And upon solving this, you are going to get how much? So solving this, you will get the value of beta as 19. So this is how you have to do. It is very simple. See, you generally electrical students as an experience, or you might know what I am telling. Basically, they feel that analog electronics is something like a burden for them. They feel very happy and very comfortable while studying some power systems or machines or measuring instruments. One thing you have to keep in mind, analog electronics is nothing but it is simply a part 2 of electric circuits. The better you do in electric circuits, the more you are having grip on nodal analysis, mesh analysis, KCL and KVL. That's it. Nothing else. You just got to remember some formulas like this. Ante. You just got to remember some formulas like this. That's it. Nothing else is there. So it is not a magic, or it's not some rocket science to study analog electronics. And I am telling this specifically because many bright electrical students I have seen in my experience, they will just leave this subject because they are frightened of this, or they don't know what is this subject. Never leave that, never leave that. It is just simple, just this much only. So anyhow, I hope this power challenge series will try to remove such kind of fear in you, because every week we are going to come up with one question, and we are going to select such questions which are basically fear points for students, because we are mainly targeted, because I cannot provide a full course up to GATE 2020, but one question is enough to change your understanding about the concept. Okay guys, thank you for watching, and don't forget to subscribe to the channel.